Many of us are taught that 0.9 repeating is just a very close approximation of 1, but in the world of mathematics, they are actually the exact same value. This often feels counterintuitive, because our brains want to treat the infinite string of nines as a process that is moving toward 1, rather than a finished number. Think about the fraction 1/3. We know that 1/3 is equal to 0.3 repeating. If you multiply 1/3 by 3, you get exactly 1. Logically, if you multiply the decimal equivalent, 0.3 repeating, by 3, you must also get exactly 1. 3 times 3 is 9, so 3 times 0.3 repeating results in 0.9 repeating. Therefore, 0.9 repeating is not just close to 1, it is another way of writing the number 1. We can prove this definitively using a simple algebraic trick that takes only a few seconds to understand. Let's set a variable, x, equal to 0.9 repeating. Now, if we multiply both sides of this equation by 10, we move the decimal point one place to the right. This gives us 10x equals 9.9 repeating. Here is the clever part. We can subtract our original equation from this new one. 10x minus x leaves us with 9x. On the other side, 9.9 repeating minus 0.9 repeating perfectly cancels out the infinite string of nines, leaving us with exactly 9. So, if 9x equals 9, then dividing both sides by 9 tells us that x must equal 1. Since we started by saying x equals 0.9 repeating, we have mathematically demonstrated that they are identical. If you still feel skeptical, consider the logic of the gap between numbers. For any two distinct real numbers, there must be at least one other number that sits between them. For example, between 0.5 and 0.6, there is 0.55. If 0.9 repeating and 1 were truly different, you should be able to tell me what number you get when you subtract one from the other. If you try to calculate 1 minus 0.9 repeating, you might expect to get 0.000, followed eventually by a 1. But the nines never end, which means the zeros in your answer never end. You will never reach a 1 at the end because there is no end. If the difference between two values is exactly 0, then there is no gap at all. Without a gap, the two values must be the same point on the number line. This concept is a fundamental part of how we define the real number system. In calculus, we view 0.9 repeating as the limit of an infinite geometric series. It is the sum of 9/10 plus 9/100 plus 9/1000, and so on forever. As the number of terms approaches infinity, the sum doesn't just get close to 1. The limit is defined as being exactly 1. This highlights a key lesson in mathematics. Numbers can have different names or decimal representations while representing the same underlying quantity. Just as 2/4 is the same as 1/2, 0.9 repeating is simply another name for 1.